Hey guys, it's G once again, and in this short tutorial we want to discuss once again about 3D Studio Max, and as you maybe can guess, about data operator. Recently I created a new intro and I used just particle for all the intro, and I find it interesting to create a tutorial and share what I had as experience. So first, let's see what we have. So as you can see, the whole intro is just based on some boxes that are growing. But the good thing here is that the boxes are different from each other and in different scale and in different timing they are coming up and down. So maybe you can do this in different ways, but I will show you the easiest way to control a large amount of boxes, how and when they should grow up and how much they should grow up and all this stuff. I mean, the whole intro is just particle and gizmo that is controlling the timing of the particle when they should grow up. So with that said, let's begin. And I prepared a scene here. It's nothing special, just it's a PF source, and if you don't know PF source, you go here and particle system, and you have PF source, and if you press 6 or particle view, you will come to the particle view, and by normal there are bunch of other things here. I deleted them. I just say a particle system and viewport and rendering the frame and 100% a multiplayer, quantity multiplayer, and in the birth stop and emit to 0, and this is the maximum amount of particle that we have, and the position excuse me, it's the volume of our particle shape. So that's all. From the other side, I can even, for the first thing, hide this. I create a box. It's just a simple box, and I made some animation with the height. You see, at frame 0 it's 0. At frame 1 it's something around 7, and once again 0, and it will grow up until, for example, 29, and it will come down very gradually after that. So why I did these first 3 keys here, it's just because it was looking better here. You see here I have the first growing up, and once again they start from 0. It's looking very good. So that was why I did this. You can delete this, of course, or whatever you want. So the first step is to calculate when this gizmo excuse me, I created a sphere gizmo, and if you go to Hopper, atmospheric, sphere gizmo, and I have some radius here, 50, and I make the animation for the sphere gizmo. It's going here, okay? The first step is to calculate when these particles are coming inside this gizmo. So for this reason, we create here data test. Okay, and we should say when they will be be in this volume. When they are in the volume, they should go to the next event. When we have the next event, we take another color, for example red, so we can differentiate. Okay, but when first update, let it be auto update, and open edit data flow. For this, first we should select our object. We select our object, and what we want from our object is the object pivot. So object here, create, and object pivot. So we have right now our position of our pivot of our sphere gizmo. So what to do with this? So here we create an input standard and say position. So this is the position of each particles individually. So we have the position of each particle and the position of the sphere gizmo. So very easy, just to, if you have two of them, you need just a function, and we say vector and vector, and what we want to have is a distance length. So we will have a distance length between this and this, and the output will be in real a number, okay, not a vector anymore. And how can we test this? How can we test this? We create object parameters, and for the object we say our sphere gizmo, and for the parameter we say radius. So we will say if this length is less than our radius, it will be the case that the particles are inside the gizmo. Very easy. So they should go to the next event. So how to do this? Output test, and for the output test we need a boolean. So when so I create a condition and create, but I will say if it's less than this value but not this value, I press here, so I can, instead of giving a constant value, I give our sphere radius. So if I here increase or decrease it, you see that it will change. So very easily we create something that sphere gizmo is traveling through our particle, and the particles that are inside this, they will go to the next event. This is the first part of our tutorial. But the second part, you see, it's pretty simple. We have until now not yet no shape for the particles, so you will see nothing here until now. And the second part is to create, to let them grow up. So once again, as you will maybe guess, we create a data operator. And in this data operator, once again, auto update and open this. I can minimize this. And first of all, we create an input standard and we say new event. So that the event, the function that I want to create right now, will happen just in the first time that each particle came to this event, particular event. So particle age, I need another input standard, and I will this time use time particle age, and I will use this as a filter. So just the first time, read the particle age, the number and the age of the particle, and store it output new. Store it as a new output, and we can rename this. For example, output new, no, output time offset, something like this, and I just connect this to here. And we go to the second part of this data operator, and the second part is to create a shape control. Shape control determines what shape our particle should have, and we select our shape control, and here particle geometry shape, instead of none we choose our box or our object. So if I close this right now and press 6 and go here, instead of ticks, let's say geometry, you will see, okay, you will see that we have right now our boxes here, but they are all of them are flat. Why? Because here in data operator, by usual, it's not animated shape, it's not checked. If I check this, what will happen right now? What will happen? You see that I will have my object here as particle, but they are all growing at the same time and with the same length as our main object. But that's not the case at all. What I want is when our sphere gizmo reach each particle, they should have their own time offset. So for this reason, that's why we created this time offset here in the first event, the first time that the particle came to this event. So how to do this? Very easy. In input and standard, I create an input standard, and here I will have time and absolute time. I create another input standard. I have already here my our input custom. I create my own input custom here, input custom, and I click it and say output time offset. So I have both of them here, and I create a function here, and I say time, okay? And I will say subtraction between this and this. So this will be our shape. You see, I have a T, it means timing, because I checked the animation. So if I scrub the timeline, you will see that when they give them reach each particle, they will begin the timing of my particle. But there is a problem, you see. First, when the sphere gizmo reach each of them, first they are in the full length, and after that they are going to the side that they should be. This is just a smart problem due to the priority of execution. So instead of saying execution order to 1 for the shape control, set it to 2 and priority to 1. So first this and after that this. This is the execution order. So if you do this, you will see that the problem is solved. So right now I have my boxes that are growing up when the gizmo reach each particle. This is the main trick of the intro that I created. And there's another thing that is good to do to give some offset for the scale. So for this I create a random and a uniform random, for example from 0.4 till maximum 1, and I create an input standard for my scale Z component and a function that instead of we should have real and what we should have multiplication, both of this, and we should have an output standard. What kind of output do we need? Scale Z component. So, but not every frame, because you see, not every, just in the first. So passing this first frame. Okay. So that is. So I have right now. What do I have right now here? I can bring it here, make it. What I have right now here, I have just one object with a certain keyframe and some particles that are growing up when this gizmo reaches them. But right now, after this, I want to show you my original scene. So I did some other changes, because if you will see closely into the intro, it's some of them also have different shapes, and some of them are flat, some of them have an angle here, and all this stuff. So for this reason, what I created, because I can I can have a variation in scale, but the timing of them, it's all the same. So for solving this problem, what I did was this. I created, for example, on hide bind, on hide all, and yeah, these are. I created 12 or 13 of them, and you will see some of them are different shapes, and even if I select all of them, you will see here I have a variation of growing up, the amount of growing up, and the amount of the timing when they are coming back. So full of random, we will see. And I choose all of this as particles, not just one. So here I have my peer source. It's just material, and this is cache. That's not a problem. You can delete both of these, no problem. It's the same with our like our own scene. And I have here the data test, but instead of sending from here to the data operator, I created here a big event, and I splitted them, and I created 12 other sub operators, and each of them had one of these. Each of these sub operators, each of these sub events they have one of this. So that's a trick that I used for creating something very random and very easy. And another thing that I use, okay, I created, because I didn't want to have the particle randomly here. You see, what I wanted to exactly know where the particles are. So I created a simple mesh, and I created some vertices. For example, I wanted another one here. I go here, cut here to here, and when I create two particles here, because right now, select all the particles, we have 234 particles, okay? And I open here, and this is because of the cache. I delete this cache, and 200, instead of 252, we say 254. And it should get updated. I don't know why it's not updating right now, but it's just the logic is this. Right now it should get updated. Maybe it's something, it's back or something. Oh, we have another cache here. Maybe it's because of this. But that's why the way that I created this particle. So with creating some simple vertices here, I determined exactly where my particle should be, and so I had the full control over the place of my particle, over growing up. And this is a gizmo. this is the gizmo, this is the big gizmo. You will see, right now I removed the cache, so it's heavy to, you will see here. And this is my gizmo that is traveling through the particles and the light that are coming along the, you will see here. So that was how I did this. I hope that you enjoyed this tutorial and you learned something so you can create your own idea with that. The basic is to working with particle, and you can do everything, I think, with data operator. Just need some concentration, what you want, and the function. And the result is very impressive. So, I hope you liked this tutorial and you enjoyed it, and don't forget to subscribe and like, and if you have any comments, you are always welcome. And if you want to have know more specific in details of this intro, just tell me and I will create another tutorial for this. But I think the main thing was just how to work with the data operator, and that is for all of the intro. So